Hello guys, this video is going to introduce the traveling salesperson problem. In short, the TSP problem. This is the first video of this chapter. So let us see what the TSP problem is about. In the TSP problem, we are given with n cities. For example, here we have 5 cities. And also, we are given with the information of distance between each pair of cities. For example, I know the distance between any two cities here. Distance between 1 to 4 or 2 to 3 or any possible pair. Now among these cities, there is one city that is considered as the start or home city. For example, here city 1 is the start city. And the salesperson is starting from the home city and he'll be visiting the cities nearby and returning to the home city. There are many possible paths that the salesperson could travel. For example, this is one of the paths that he will travel and reach back to the home city. This is another path. Now let us formulate the problem using graph theory notations. Now each city is represented by a node and the distance between the cities is represented by the arc. Here the distance is represented by a number adjacent to the arc. Now, the main restriction of the traveling salesperson problem is to make a tour. What is a tour? Tour is nothing but visiting all the cities only once and returning back to the start city. This tour in general is called as vertex tour or Hamiltonian tour. For example, here we have one tour. Starting from city 1, visit 2, 3, 4, 5 and back to 1. This is how it looks graphically. Now if you calculate the total tour length, it will be 51 kilometers. It is the total distance that you have to travel from city 1 to visit all the cities and come back to city 1. Now here is another tour, that is to start from city 1, then 3, 5, 4, 2 and 1. This is how it looks graphically and the total tour length is 91 kilometers. So the objective of the TSP problem is from among all the possible tours, find the tour of the shortest length or find the shortest tour. Let us look at some of the examples of the TSP problem. We have the world exploration example here. The idea is starting from your hometown, visit all these cities and return to the hometown. Now the goal will be to minimize the total travel time that you spend by moving from one city to another city. Here is another example of the circuit board manufacturing. Imagine you are manufacturing a circuit board and it requires various components to be installed on it. In order to install these components, you need to drill the holes. Let us say you are using a drill machine to drill the holes. And starting from this red dot, you would like to visit all the white dots and return back to the red dot in shortest possible time. And if you do so, you will manufacture this circuit board in the shortest possible time. Here is another example of production facility. Imagine you are manufacturing t-shirts of different colors and as a standard approach, you will be manufacturing the t-shirts in white color and using a paint machine to color the t-shirts. Let us say you fill the paint machine with yellow color first and then you start manufacturing the yellow t-shirts. Once you are done with manufacturing the required number of yellow t-shirts, you change the color. And then you start manufacturing blue color t-shirt. Once you are done with manufacturing of blue color t-shirts, you will change the color. Now once you change the color in the paint machine, you will see that for certain amount of time, you will neither get the blue t-shirts or white t-shirts. You will get some mixed t-shirts, which let us say we scrap. So when you move from one color to other color, there could be some mixing of color and those t-shirts will be considered as scrap t-shirts. For example, here we are assuming when you go from yellow to blue, there are 0 scraps. When we are going from blue to white, there are 100 scraps. And after so many scrap t-shirts, you will be manufacturing white color t-shirts. And once you are done with manufacturing the required amount of white t-shirts, you change the color. Once you are done with manufacturing the required amount of t-shirts, you change the color. And once you are done with the required amount of t-shirts, you change the color. So as you see, the sequence of color that you follow in the paint machine will give you some scrap t-shirts. For example, here you have the first sequence that you follow, you will end up with 170 scrap t-shirts. Whereas if you modify the sequence, then you will have 18 scrap t-shirts. And for the production facility, coming up with a sequence which has the least number of scraps is profitable. So the goal will be, given so many colors, what should be the right sequence of colors such that we have the least number of scraps. Apart from these 3 examples, there are many more examples in the text. Please read the TSP applications part from the textbook. Now let us see the difficulty of solving the TSP problem. We are going to start with a 5-city TSP problem. A feasible solution to the 5-city TSP problem will be going from 1, 2, 3, 4, 5 and returning back to 1. Now for a 5-city problem, if you start from city 1 and end at city 1, there are 4 possible cities that can be placed in the second place. Then there are 3 possible cities that can be placed in this place. Here you have 2 possible cities and then here you have the last remaining city. So the total combinations or the total tours that you can get from the 5-city problem is 4 factorial. And among these 4 factorial solutions, your goal is to find the optimal or the shortest tour. So to solve a 5-city TSP problem, all you have to do is obtain those 4 factorial, which is nothing but 24 tours, and pick the one that gives you the shortest tour. Similarly, for the n-city problem, you will have n minus 1 factorial tours, and from this you can pick the minimum. That's it. The problem is so easy. Let us take, for instance, you have a 31-city TSP problem to solve, and you have a supercomputer that has 1 petaflops of computing power. That means you can perform 10 to the power 15 operations per second, roughly. Now let us see, using this supercomputer, how long it will take to solve a 31-city problem. Can you guess how long it will take to solve this 31-city problem using this supercomputer? It turns out that it will take 8.4 into 10 to the power 9 years to solve this TSP problem. So you see, if you go with the complete enumeration methods, even though you are using a supercomputer, you will take a good amount of time to solve some trivial TSP problem. In fact, during this time, you can visit the 30 cities and return back to the home city multiple number of times. So there should be a better way of solving the TSP problem, and OR, Operation Research, is the way to solve the TSP problems. This TSP problem is very old problem, but it was popularized during 1800s. This figure here shows how the TSP problem is solved during the years. On the x-axis you have the years, and on the y-axis you have the number of cities or nodes that you had in the TSP problem. Currently, the maximum number of nodes that were solved for a TSP problem is 85,900 cities or locations. It was a VLSI application. It was solved during a period of 1 year, during 2005 and 6. More details can be obtained from this link. In addition to that, the TSP problem is related to one of the problems of the millennium, and you can follow this link to know more about this problem. Now, the TSP problem can come in many flavors. For example, it could be a symmetric TSP, it could be asymmetric TSP, it could be open tour TSP. In symmetric TSP, we have distance from city I to city J is same as distance from city J to city I. One of the examples for the symmetric TSP could be the circuit board problem. In asymmetric TSP, the distance between city I to city J is not same as distance from city J to city I. An example for this asymmetric TSP could be the world tour problem. In the open tour TSP, you are not required to start from a home city and end at home city. One of the examples for this TSP could be the t-shirt manufacturing problem. For the closed tours, this is something important and you must remember. Let us say your home city is 1. So that's one of the tour, 1, 2, 3, 4, 5, 1. This tour can be represented in many ways. For example, here it is represented like this, 2, 3, 4, 5, 1, 2. This is same as this tour. Similarly, pick any tour from here and it is same as this tour. Now that is all what we have in the introduction. In the next video, we are going to see some of the exact methods that you can use to solve the TSP problem.